Hey there, everyone! Welcome back to our channel. If you're new here, don't forget to hit that subscribe button to stay updated with all our exciting educational content. Today, we're diving into a fascinating topic that's making waves in the tech world: vector memory for large language models, or LLMs for short. Now, this might sound a bit complex, but don't worry. We're here to break it down into simple and digestible pieces. So, let's get started. Now, you might be wondering, what exactly is vector memory, and why is it important for LLMs? Great question! To understand this, we first need to get a grasp of what vectors are and how they're used in machine learning. Let's start with the basics. In mathematics and computer science, a vector is essentially an array of numbers arranged in a specific order. Think of it like a coordinate in space, a collection of attributes that defines a point. For instance, if you have a vector that represents a word, it might contain numbers that correspond to various semantic properties of that word. Now, in the context of LLMs, these vectors are crucial because they help the model understand the relationships between words. Instead of treating words as isolated entities, LLMs use vectors to capture their meanings in relation to one another. This process is often referred to as word embedding. For example, let's consider the words king and queen. In vector space, these words are not just random points, they're positioned relative to each other based on their meanings. The distance and direction between the vectors of king and queen can reveal deeper relationships, like gender. In fact, if you take the vector for king, subtract the vector for man, and then add the vector for woman, you'll get a vector that's very close to queen. This is the magic of vector representations. However, as LLMs grow in complexity and size, they also require more sophisticated memory systems to handle the vast amount of information they process. And that's where vector memory comes into play. Vector memory is an innovative way of storing and retrieving these vectors efficiently. Traditional memory systems may struggle with the sheer volume of data LLMs use, especially when they're creating contextually relevant responses. Vector memory allows models to quickly access embeddings and retrieve information based on similarities and relationships. Imagine you're chatting with an AI and you ask it about a specific topic. Instead of scanning through a massive database of text, vector memory allows the model to quickly find the closest vectors related to your query. This makes the process faster and more efficient, enhancing the overall user experience. Let's look at an example to clarify this. Suppose you're using an LLM to generate a story. You provide it with a prompt about a dragon and a princess. The model needs to recall various facts, stories, and relationships about dragons, princesses, and even the settings they typically inhabit. With vector memory, the model can pull up relevant vectors associated with these concepts swiftly, allowing it to weave a coherent and engaging narrative. Now, it's worth noting that vector memory can be implemented in various ways. One common approach is using approximate nearest neighbor search. This method enables the model to find the closest vectors in a high-dimensional space without having to sift through every single vector. It's like having a super-fast index that helps you locate the information you need in a gigantic library. In fact, recent advancements in vector memory have shown significant improvements in the performance of LLMs. Studies indicate that models using vector memory can generate more contextually aware and relevant responses, making interactions feel more natural and engaging. For instance, OpenAI's GPT models have been leveraging these techniques to enhance their conversational abilities, resulting in a more seamless user experience. Moreover, as LLMs continue to evolve, the concept of vector memory will likely expand. Researchers are exploring ways to improve the efficiency of these memory systems, enabling models to retain even more information and provide responses that are not only contextually relevant but also nuanced and sophisticated. So, to wrap it all up, vector memory is a powerful tool that enhances the capabilities of large language models by efficiently storing and retrieving vector representations of words and concepts. This technology allows LLMs to generate responses that are not only accurate but also contextually rich, making our interactions with AI more engaging. If you found this video helpful, please give it a thumbs up. And if you have any questions or comments, feel free to drop them below. What do you think about the future of vector memory in AI? We'd love to hear your thoughts. Don't forget to subscribe for more fascinating insights into the world of technology and AI. Thanks for watching, and we'll see you in the next video.